Hello and welcome to Electronic Solutions. This is the next video in the series of 8051 microcontroller. So if you are new to the channel, then please subscribe the channel and hit the bell icon for the latest notifications. Before starting discussion of the pin diagram of 8051, let us first discuss some important features of this controller. Intel introduced 8-bit microcontroller in 1981, which is nothing but 8051. 8051 contains 128 bytes of RAM, 4 kilobytes of on-chip ROM, 2 timers, 1 serial port and 4 IO ports which are 8-bit wide, all on a single chip. And because of that, this system is termed as a system on chip, as it contains all these components present on the single chip itself. There are various family members available for 8051 microcontroller, and these family members, they come in different packages such as dual inline called as a DIP package, QFP, that is a quad flat package, and LLC, which is a leadless chip carrier package. They all are having 40 pins which are dedicated for various functions such as input output, read, write, address, data and interrupts. So let us start with the discussion of 8051 microcontroller pin diagram. So as you can see in the pin diagram, it is basically a total 40 pin IC and it is a dual inline package, that is it is a 40 pin DIP package. Now we'll go through all these pin details one by one. Now here in the diagram, as you can see, pin number 1 to pin number 8 are dedicated for the IO port P1. So see, pin 1 to 8 is for port 1 and this port is a bidirectional input output port and it is internally pulled up. That means it is not necessary to connect any external pull up resistor for this port 1. Also this port is not performing any dual function, so it is only dedicated for IO port only. This is about the port 1, that is from pin number 1 to pin number 8. Then next is a reset pin, which is a pin number 9. This reset pin is basically an active high pin, but the normal status of the pin is low. So in order for this reset to be effective, then this pin must be made high, and the duration for which we should make it high, it must be of minimum 2 machine cycles. So meaning is that the high pulse must be high for minimum of 2 machine cycle, and then it is allowed to go low. Then only this reset pin will get activated. Activating a power on reset will cause all the values in the registers to be lost, and it will also set your program counter to 00. Now whenever we apply a high pulse to this reset pin, the microcontroller will reset and it will terminate all the activities. Now there are two ways by which we can reset this circuit. So the first is called as a power on reset. So in this power on reset, you can see that to the pin number 9, which is the reset pin, it is connected between one capacitor and one resistor. The value of resistor is 8.2K and capacitor is 10 microfarad. So when the power is turned on, this circuit holds the reset pin high for the amount of time which depend upon the capacitor value and the rate at which it charges. And to ensure this valid reset, as we have discussed, the reset pin must be held high long enough to allow your oscillator to start up plus 2 machine cycles. So that means your reset pulse must be high for at least 2 machine cycles and then it should go low. So accordingly we have to set the value of this resistor and the capacitor. So this is one type of reset circuit which is called as a power on reset. There is another type which is called as power on reset with momentary switch. Now in this case there is one switch connected across the capacitor, and when that switch is pressed momentarily, then the VCC will be connected to that reset pin for a movement. So that is also one of the another reset circuit used for the 8051 microcontroller. Now whenever the microcontroller will get resetted, then the values of some of the registers are as follows. So your program counter will be loaded with the value 0000. The DPTR pointer also loaded with 0000. Accumulator loaded with 00. PSW, that is a program status word, also loaded with 00. But the stack pointer is initialized to the value 07. Register B contains 00, and all the ports, that is from P0 to P3, will be allotted the value FF. So that means these are the different reset values for the different registers of 8051 microcontroller. Now next to that, pins 10 to 17. So pin 10 to 17 are for port 3. So again we'll go back to the pin diagram slide and we'll see. So see here, pin number 10 to pin number 17 is dedicated for port 3. But see here, along with this port 3, it is also performing some dual functions along each pin. So what are these functions? So let us have a look at that. So port 3 is again a bidirectional input output port with internal pull up registers, and this port 3 bits and the pin function description is as follows. So this port pin 3.0, which is a pin number 10 of your microcontroller, will act as a port pin, plus it will act as a serial pin RxD for serial input. Pin 3.1 is pin number 11 for TXD serial output. Port 3.2 pin number 12 is for external interrupt 0. 3.3 is for external interrupt 1. 3.4 and 3.5 are for timer inputs. 3.6 is for writing external memory write. 3.7 is for reading, that is from external memory read. So this port 3 basically performs the dual function. Now we'll go for the next pins, that is pin number 18 and pin number 19. So these pins are used for interfacing an external crystal to get the system clock. So there are two ways by which we can achieve this. Now remember that 8051 has an on-chip oscillator, but it requires an external clock to run it, and a quartz crystal is normally connected to the input crystal 1 pin number 19 and crystal 2, that is pin number 18, and this quartz crystal oscillator connected between these two pins, it also needs two capacitors, that is C1 and C2, whose value is 30 picofarad, and the another end of the capacitors is connected to the ground terminal. And this oscillator frequency or this speed basically refers to this maximum oscillator frequency which is connected to the 8051 microcontroller. So the normally we use a crystal of 11.0592 megahertz for this pin number 18 and 19. But if suppose we are not interested in using the internal crystal oscillator, then in that case we can go for this option, which is the second option shown in the diagram. And here we can use an external oscillator, which is an external TTL oscillator, and that is connected only to the crystal 1 pin, and in that case the crystal 2 pin is left unconnected. So by these two methods we can generate a system clock. So this is about the pin number 18 and pin number 19. Now next is a pin number 20, which is for ground pin, and this provides the ground to the circuit. Then next is pin number 21 to pin number 28 is for the port 2. So this is again a bidirectional 8-bit input output port, and it also has an internal pull-up registers. Now here, besides this input and output action, when the external memory is interfaced, this port 2 pins acts as an higher order address bytes. So if in the pin diagram, if you can see, then the port 2, which is from 21 to 28, is multiplexed with A8 to A15, that is nothing but a higher order address byte. The next pin is a pin number 21, which is a PSEN bar. That PSEN bar stands for Program Store Enable pin. So it is used to read the signal from the external program memory. So whenever you are accessing the external ROM or external program memory, then in that case this program store enable will read the signal from that external program memory, and this pin is basically an output pin, and it is normally connected to the OE pin of the ROM, external ROM, which you are going to connect. This is about the signal PSEN bar. Then next is pin number 30. Pin number 30 is for ALE slash PROG. So ALE basically stands for the address latch enable, and this is an output pin, and this is an active high pin basically. And when uh, the controller is connected to the external memory, then this port 0 basically provides both address and data, and basically this controller multiplexes the address and data through port 0 for saving the pins, and the role of ALE pin is used for the demultiplexing of this address and data by connecting to the G pin of the 74LS373 chip. So we have to connect one external 74LS373 chip, and you have to use the G pin for that, for demultiplexing the data and the address which is connected. So for that purpose this ALE pin is used. Now there is one more a function, that is a PROG bar. So this PROG bar is basically used during the flash programming, and during this programming this pin acts as a program pulse input. Pin number 31 is EA bar slash VPP. So EA bar pin stands for external access input. So it is basically used to enable and disable the external memory interfacing. So we know that there is a on-chip ROM of 4 kilobytes, and externally we can interface maximum of 64 KB. So whenever this external ROM is to be connected, then in that case this EA bar pin plays an important role. So when we keep the EA bar is equal to 1, then it will access the on-chip ROM which is of 4 kilobytes, and whenever along with some external memory, and when EA bar is equal to 0, then in that case it won't access any internal ROM, but it will only access the external ROM memory. So that is what is the function of EA bar, which stands for external access input. Then pin number 32 to pin number 39, they are basically stand for port 0. So port 0 is also designated as AD0 to AD7, which allows it to use for both address as well as the data. So ALE again indicates if port P0 has an address or data. So if we put ALE is equal to 0, then it will give us a data from D0 to D7, and if ALE is equal to 1, then it will give us an address from A0 to A7. Now here this port 0 pins, they can be used as an input or output, but in this case they are not internally pulled up, and therefore here each pin must be connected externally to one pull up register which is of value 10K. So only for this port 0 we have to connect the pins to the external pull up registers, but for all other ports there is an internal pull up is available. So this is what all about this port 0, and the last pin is the VCC pin, that is a pin number 40, and that pin number 40 is basically for providing the VCC to your controller, and that VCC is equal to plus 5 volts. So this is what all about the pin diagram of 8051 microcontroller. So if you like my video, then please share the video with your friends and also like and subscribe to my channel. Thank you guys. Thank you so much.